So today, what we're going to look at is finding the electronic characteristics of single resistors in a combination circuit. So we can find like the voltage, the current, the power for a single resistor in a crazy complicated circuit. Okay. So step one. Well, first off, I want to figure out the current going through this bulb here. So step one is to find the total or the equivalent resistance. So go ahead and do that and redraw the circuit. So what are the chances you think you're doing better in class if you didn't watch your phone all the time? So the killer is, if you go to college, they'll just say, I got your money, play on your phone. It doesn't matter. Does that make sense? Like you gotta learn how to, it's a good tool. Yeah, so what's your first grouping? So circle those. Are those in series or parallel? So go ahead and do the math for that. They're 10 ohms. So I'll do it lightly up here, and you can do it with your markers. That needs to be 10, not 1. Oh, yeah. Okay. Yeah. Yes. Good. All right. So parallel, redraw. Series, redraw. Good with that? Okay, that is step one. Now, the reason why I have you redraw the circuits is to give you stepping stones to get back to this. We're looking for the current in bulb 2. To find that, we're going to find information at each stage, at each level, at each lily pad, at each Hansel and Gretel breadcrumb, whatever you want to use your analogy. We're going back to where we started, where we do something at each level. Okay. What do? We're going to find all three measurements of the resistor that I care about at each level. I want to know the voltage, I want to know the current, and I want to know the resistance at each level for the resistor that I care about. Okay, so problem tells me I have a 15-volt battery. I only have one resistor here, so the voltage gain equals voltage drop. There's 15 volts across here. So I have 15 volts is equal to current times resistance. So the current, I made this problem so I didn't have to use a calculator as I'm going through it, is 1 amp. Okay, so now I know all three measurements for that one resistor. Okay, so this is the total. Well, I just found the total. I had the total resistance. This is the total voltage. This is the total current. Good with that? Now, once I have all three for the resistor I care about, I bring it back. I take one step back. Okay, the 5 and the 10, sorry, the 15 came from the 10 and the 5 wired how? In series. Okay, what measurement is the same in series? Folks, that needs to be on lockdown. Okay, that factoid, current, oh, sorry, series. Oh, current's the same. Like, that's got to be right there. Okay, so the fact that this wired in series, I can take this current measurement, and that is the current going through the 10 and the 5. Because it's in series. Okay, so I now know that there's 1 amp going through this guy and 1 amp going through this guy. Okay, just take a peek at this. If I have 1 amp going through the battery, these are in series, so it has to be 1 amp through here and 1 amp through there. It has to be. All right with that? Now, which of these two resistors do I care about? The 10 or the 5? Where's the 2 buried? In the 5 ohm resistor. So that's the one that I should find measurements for. Well, I've got the current, I've got the resistance. The only thing I'm missing is the voltage. Voltage is equal to current times resistance. 5 volts. I know there's 5 volts across that guy. You good there? Now, the 5 came from the bulb 2 and bulb 3 wired how? Parallel. So what measurement is the same in parallel? Voltage. Lockdown. That is a hard fact that you need to like have in your brain. So there's 5 volts across this one and 5 volts across this one. Sorry, voltage is the same. Good with that. Last step. I'm looking for the current from bulb 2. I have the voltage. I've got the resistance. All I need is the current. So 5 volts is equal to current times 10 ohms. 0.5 amps. Okay. Quick review. I boil it down to one resistor, redrawing every step. And then I find all 3 pieces, all 3 measurements at each stage, at each step, at each lily pad for the resistor I care about. Resistance, voltage, current. Resistance, voltage, current. Okay. If this comes from series, then the current you draw, you use the current in this one and apply it to these 2. If voltage is the same, sorry, if voltage, blah, 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 if these came from these in parallel, then you take the voltage, because voltage is the same in parallel, and apply it to there and there. And you continue to do that. I know I gave you an easier circuit here, but you use that pattern however many steps it takes. Okay? Folks, this is like, when I was in your shoes, this was like, oh, this feels like math class. Like, all I need to do is repeat this procedure and I get the right answer. Okay? The part that, in terms of, is the hardest would be getting it down to one resistor. But bringing it back, if you're faithful with these steps, you're going to get the right answer. Okay? Here's 2 sources of error. This is actually the most popular way people miss it. Most people can get down to 15 ohms, boil this down, whatever the circuit is, get down to the right one. And they can find the total current. But then what they do is they prematurely take this and like, oh, and you bypass all the intermediary steps, taking this total and applying it to an individual, and like, you must, and those are the people that usually don't redraw the circuits, by the way. You have to find the calculations at every step. Okay, good with that. The second source of error, and this is just brain fart type stuff. You have a lot of numbers, and you're like, you got a 5 and you got a 5 and a 1, and you're like, and you forget which measurement, and you're like, if you write down their units, it helps. It's good bookkeeping. Okay, good with that. Okay. Next slide is just the cookbook recipe for doing what we just went through. So if you need something to jog your memory, I got that PowerPoint. Okay. Now, for this next slide, what I'm going to do is I'm going to find all the information about all the variables for proof of concept. Okay. So here, this guy, I need the voltage. So voltage is equal to current, 1 amp, times resistance, 10 ohms. So the voltage across this guy is 10 volts. So it's 10 volts here. So what I'm going to do is I'm going to harvest all this information that I just calculated, and I'm just going to use the data rather than all the calculations to make this next point. Okay, so the numbers that I'm writing down came from what we just did here. Okay, this guy had 10 ohms, 10 volts, and 1 amp going through that. This one had 10 ohms, 5 volts, and 0.5 amps. This one, because this is identical and in parallel, this had 10 ohms, 5 volts, and 0.5 amps. That's all the data. Like, we already calculated all that. Okay. What I'm going to do is proof of concept, Kirchhoff's loop rule and Kirchhoff's junction rule. Okay. So the loop rule says this: for every loop, the voltage gain, the total voltage gain equals the total voltage drop. Okay. So here I have a 15 volt gain, meaning I have a 15 volt high ladder. Oops. Okay. As I go across this one, I'm dropping 10 volts. So I got a 10 volt slide. And then as I go through this one, I have a 5 volt slide. Good with that. And if I take this loop, I get the same thing. So regardless of the loop I do, the voltage gain equals the voltage drop. Good with that. And the junction rule says the current in equals the current out. Here's a junction. The current in is 1 amp. The current out of this junction is 0.5 amps and 0.5 amps. In 1 amp equals out 0.5 plus 0.5. And that will always work. On this junction, it's 0.5 going in, 0.5 going in, 1 going out. Okay. Your Kirchhoff loop rule and junction rule, these will always work regardless of how complicated the circuit is. It is a good safety net checkpoint, double check thing. Okay. This is the conservation of energy. This is conservation of charge. Like, these are tried and true stuff. Okay. I don't care how far you go in electronics, loop rule and junction rule will always work. Okay. So that's the thing. All right. I want to know the power dissipated by the 5 ohm resistor. I'm going to give you a head start. What you're trying to do is find the voltage across the 5 ohm resistor first. Okay, I'm going to give you a head start, and then I'm going to follow you up and give you checkpoints along the way. Go. Found your total resistance to be 4/3 ohms. That's a checkpoint. How do we do? Okay. Some people ask, hey, could I do these in series and then the 3 and 4 in parallel, and then add the 6 and whatever this gave me in parallel? Yes. That's valid. How did you get work? So you end up with 9/12. You get 2/12 plus 4/12 plus 3/12 gives you 9/12. Gives you 3/4. Okay. Now, 9 amps is coming out of the battery, so that's your total current. 9 amps is flowing through that resistor. Again, you're looking for the voltage across the 5 ohm resistor. Continue to race ahead of me. And the total voltage would be 12 volts across this. 12 volts across that, 12 volts across that, 12 volts across that. Just in parallel. There's 2 amps going through that. The resistor I care about. So there's 2 amps going through that one, 2 amps going through that one. $10-volt drop across that resistor. And finally, power is equal to current times voltage. Power is equal to 2 amps times 10 volts. Equals 20 watts. How do we do? If you didn't get the right answer, you see where you missed it and why it's wrong, so you don't make the same mistake again. Yeah. Okay. Yep. Okay. Good there? Questions? If you are faithful with these steps, you will get the right answer, as long as you don't do any dumb brain farts. Okay? Okay, last question. But I'm going to erase all this. Any points of confusion? Any points of clarification? Like why? What? Any of that? Okay. This question here is a little different because I gave you information about an individual resistor and not information about the total circuit. So you're going to be using concepts and some math to figure this out. But I gave you clues to an individual, like the characteristics about an individual resistor rather than the total. So this is going to look different, like the problem solving with this is going to look a little different.
Sorry, I should have asked this earlier, but I don't understand how you put more up. I understand this is 6 amp because it's added together. How are we able to combine like this whole circuit here?
It's like pulling out the 6, 3, and the 4 all together.
So, okay, so because if we pull this out, it doesn't affect. Are we just doing that because if you pull any of these out, it
All of
doesn't
them.
affect.
All of it. Right, yes. Okay, so one at a time, that
Yeah.
tells us, oh, parallel. But if I pulled all three of those out,
It
it would be the same thing as if I pulled just that one out. So I'm making these into one resistor.
Okay.
Yeah, no, not so much.
What?
That makes sense? No.
Like,
Okay, so you pull them out one at a time to figure out, is it parallel or series? Okay. And then we're combining them together.
just because it doesn't have to
So we're pretending that what would it look like if all three of those were combined together to be one resistor.
Okay.
That's where the equivalent resistance, that term, comes from. Like we're drawing the equivalent resistance, like what would the resistance be that's equal to all of that?
Resistor.
Yeah.
This one. Why do you use this one to calculate the power?
Because good question. Because it asks for the 5 power dissipated by the 5 in the question.
I didn't write the question.
Okay. Yep. All right. For the sake of time, here we go. So I'm using Ohm's law like crazy. That's normal. Okay. Here I've given you the current and the resistance. I'm going to find the voltage, 12 volts, across that one resistor. This resistor, the 6 ohms and the 3 ohms are wired how? Series or parallel? Parallel. So what's the same in parallel? Voltage. So I know there's 12 volts across that. That makes sense? Okay. Now, I can find, what am I missing on that one? Current. Find that to be 4 amps. Okay. This junction here, I've got 4 amps going to here, and I've got, based upon what it said here, 2 amps going here. So what's going in? I got 2 amps, 4 amps, 6 amps is going in. Correct answer is 6 amps. So it's a different strategy if I give you stuff about an individual resistor. Versus in the previous problem, I gave you stuff about the whole circuit. Does that make sense? This was the whole circuit. Current coming from the power supply. This is I gave you current through an individual resistor. Okay? You got a lab quiz tomorrow. Okay?